now or what you had then, okay? We're going to kind of start looking at patterns like that. And those patterns are called, what kind of rules here? Recursive rules. So here we go with this, kids. We're gonna work together a lot on this one right here, I think, all right? I think you're gonna get good at this, but the notation is gonna look a little goofy for you. So think about that next, now, and then terminology as we go through this, okay? So the question is, how do you find a sequence recursively, okay? Something that happens over and over again, okay? You guys are really good at finding patterns, and I think if you're good at finding patterns, then this is gonna be a pretty easy section for you. So first thing we're gonna look to do is what? Okay, so we're going to come up with some value for something. We're going to write recursive rules for sequences. This is going to be important right here. This second goal right here, this is going to be important today. All right, third thing we're going to do is we're going to translate between what's called a recursive and an explicit rule. Everything we've done in this chapter so far, we write a rule for the nth term. It's been an explicit rule. The new type of rule we're going to write today is called a recursive rule. And then we'll look at some real life problems that involve this recursive rule writing today. Okay? So the vocabulary, here we go. 2 words, pretty easy. The explicit rule. Okay? You've done this. You have done this. Okay, so an example might be an arithmetic sequence. You've written a rule for an arithmetic sequence. You've written something like the nth term equals, I don't know, like 8n plus 7. Okay, that's an explicit rule for the nth term. So if I wanted to know the fifth term, in that explicit rule, what do I have to do to find the fifth term in? From what we've learned in the past. Plug in 5. What would the fifth term be here? 47, okay? You've also written geometric functions, haven't you? Like the nth term is equal to, I don't know. Give me an example of a geometric function. Or a geometric sequence. Anybody? Six times what? 3. To the what?
4.
N minus 1. Okay, now if I want to know the fourth term, what would I do to get the fourth term? Plug 4 in for what? N. Okay. These types of rules are called what kind of rules, kids? Explicit rules. You've done those before. Okay, you just haven't been told they're explicit rules yet. Now you have. All right. Now the ones that are going to be new for you today, guys, are what kind of rules? Okay, recursive rules are goofy. Recursive rules are always going to have 2 parts. Okay? Recursive rules are always going to have 2 parts. It says a recursive rule gives the what, kids? Well, it's always going to give you what term you're starting. Kind of like the first term. Okay? So the beginning, it's always going to give you the first term. So the first term, typically you are going to know that. Okay? And then the second part is going to relate the following. And this is where it gets kind of goofy. You're going to write a function that's for the nth term, but the nth term might be based on a previous term that we denote as a, and then subscript down there n minus 1. Now here's what I want you to kind of understand today about this. Notationally, things will get a little tricky, but here's what I want you to put down here. Okay? If you can think of a of n right here as the next value in our sequence, a of n is kind of like the what value again? The next value, and then a of n minus 1 is kind of like the number you have right now. Okay? Think about it, kids. Up here on the board, what was the next number in line that we just found? That was the 7th term. What's 7 minus 1? So if n was 7, n minus 1 would be the 6th. That's what we had right now. Okay? All right? What if I had to use the 5th term to make up for this? And if I had to use the 5th term to make the 7th term right here, the 6th term would have been n minus 1. A of n minus what would have made the 5th term? Going from 7 down to 5, how much would you have subtracted? 2. Okay, and you'll see that here, all right? I think it would be good for you guys to maybe highlight this or box this in. Okay? So I want you to think of recursive rules. If you have to see an a of n, think of a of n as the value that comes what? Next. And the a of n minus 1 is what you have right now. Okay? So let's start seeing if we can do this here. Okay? So recursive rules are going to have how many parts? 2. Okay. And the 2 parts are going to be, first of all, they got to give you this, they got to start. They got to start. They're going to give you the first term. This is what you know. Okay? Then you got to write some rule that gives you the next term based on what you have right now. Let's see what we have here. Ooh, write the first 6 terms of each sequence. You think we can do it, kids? Okay, what's a of 0 say? Okay, starts with 81, right? All right, no problem. Okay. All right. What's a of 0, isn't it? I'm going to change this quickly. What value does that equal? Okay. Well, watch this. This is what they start with right here. This part right here is your start. No, they could be A28 if you wanted it to be. They can start with 28 terms if they want. Okay. We need to give the first how many terms? Have I given the first one right here? Okay. What's that?
How is A of 0 something?
So this is kind of like, if you were going to plot this on a graph, this would be kind of like the point 0, 81. So they're kind of like saying when your input is 0, your output is what? 81 right here. Okay? All right. Now think about this. This is the rule that they give you right here. They say, okay, the next term is equal to what you have right what? Times what? Yep. So it would be 81 times 1/3. And think about this. If I plug 1 in here, what's 1 minus 1? Doesn't this become a of 0? But a of 0 is equal to what value? So this part is like saying, ooh, we got to use that 81 that we just had, right? Okay. So what would a of 1 equal right here, kids? It's really 1/3 of what? Which is? Yep, this would equal 1/3 of 81, which is 27. Now think about this, kids. How many terms have I given so far? 2. Okay. They say find a of 2. Okay, well think about this. The second term, a of 2, is going to equal 1/3 of a of 2 minus 1. What is 2 minus 1 here?
1.
So isn't this like the first term then? Or a of 1 here? Well, what was a of 1 equal to, kids? So won't a of 2 equal 1/3 of what we had prior? So 1/3 of what? Okay, now hear me out on this. Okay. What is 1/3 of 27? Okay, what do I have right now?
Oh, you're just going down, dividing the 3.
We're just going to keep multiplying what I have right now times what?
1/3.
1/3. So what do I have right now? 9. The next term would be A3. What are we doing to the now term to get to the next term? Times me by 1/3. So if I have 9 right now, what's going to be next? 3. Okay, what do I have now? 3. So the next term will be 1. Okay? How many terms have I given so far? 1, 2, 3, 4, 5. If I have 1 right now, what's next? Okay. All right. So up here they kind of give us a different notation on the top right. Same thing. We're going to give 6 terms. Yes. Yep. Okay. This is kind of like saying f of 1 is equal to what here, kids? They're starting you at 23. And then they say f of n minus 1 minus 6 defines the next term. So what do we have to start right here, kids? Okay, here's our start. Yeah. And I'm going to show you here in a second here what's going on here. This here is going to be kind of our recursive rule right here. The second one, this is going to be the recursive rule right here. Okay, now when they give you this notation, don't let it fool you. When I say f of 1 is equal to 23, kids, this is just like saying a of, what value do they have in here? Equals what value? Okay, so here's the deal. Right now we are what? At 23, right? Okay, so my next term will equal what I have right now minus what? Okay, so my next term, a of 2, is going to equal what I have right now. Okay, let's think about this. This f of n minus 1 is like a of n minus 1, all minus 6. Okay, second term, guys, plug 2 in here. What's 2 minus 1? And that's like the first term, which was what? So this part really is what value to start right here, minus how much more? Okay, so the next term has to be what? Okay. Now you have 17. What must come next? This is the part you have right now, right? Now minus 6 is going to make your next value. Okay, so A3 must be what? Yep. What I have right now, we're just subtracting what? Okay, fourth term. What's next, kids? 5. Okay, we're at 5 now. What must be next? Negative 1? Okay. We got to get what, the first 6 terms? How many do I have so far? 5 of them? Okay, so a of 6 is where I'd be. Now I'm at negative 1. What must come next according to that rule? Negative how much? 7. Negative 7. Good. Okay. You okay with that? Okay. How many parts to a recursive rule, kids? First part is where you are now, or where we're going to start, right? And then the second part is how do you take right now and turn it into the next number. Okay, so let's look at that. Okay, I think writing the first 6 terms I think is doable. By the way, what kind of sequence would this be right here with these numbers? Would this be geometric or would this be arithmetic? This is going to be geometric because I keep dividing by how much each time. What's this going to be? Because I'm going down by 6 each time, right? Okay. All right, let's see what's on this next part then. So,
You said we're not going to get it.
yeah, we're not going to get close to being done. I promise you. Okay. So I got to write a recursive. Okay, this right here, kids, this word right here, this means something. It says write a recursive rule. So I've got to have a certain number of parts. How many parts? Gotta have a start. Where am I starting? Okay. Well, I would probably assume that negative 11 is which term here, kids, in this sequence? First one, right? So for your start here, I would say, okay, your first term is equal to negative 11. That's a negative sign there. Okay, now guys, what's happening? What's the pattern in this right here? Adding 5 to the previous one. So right here, right now, if I'm at negative 11, how do I get to my next value? Well, you would say do what? Add 5, right? Okay. So here's how you write your rule for this. Here comes your rule. Okay. If you go back to the front side of your notes and look at the vocabulary, we said we have to write a rule for the nth term. We say the nth term, or the next term, is equal to the... Okay. If this is the second term, what was this term right here? First. How many positions before the second term is the first term? So if I want to get to the nth term, this term has to be how many positions back to get to the next term. So this is going to be a of n minus 1 And then what are we doing to that now term to get to the next term? We are plus 5 here. Okay? And that would be your rule right there. All right? So again, first part of this is to do what? Okay, so A1 is equal to negative 11. Okay, the rule then is going to state that, okay, I'm at negative 11 now, so the next term, A2, has to equal the now term, A1, right? Aren't 2 and 1 apart from each other? You understand why this is n and n minus 1 now? Okay, and then why the plus 5 here? The plus 5 is the pattern, or what's happening in this sequence. Okay? Let's try another one here, kids. First of all, tell me to start on this. So A1 equal 24. Is that cool? All right. Friends, tell me what the heck is going on for a pattern. Dividing by 2 everywhere? All agree? So you're telling me, take what I have right now and do what? So the next term would equal what I have right now divided by what? How am I going to write that in recursive notation then for the rule? A of n equals. There you go. That's it. You understand the start part?
This term
So
A minus 1.
Yeah, typically A of n minus 1. Now we'll start looking at some minus 2s here in a second. Okay. Okay. But the A of n, it's just like saying this. This A of n and A of n minus 1. If I'm looking for the 17th, this is kind of like saying if I'm looking for the 17th term, then what term would I need to know to find the 17th term? 17 minus 1 would be 16, right? This is saying if I want the 17th term here, I would need to know the 16th term to get that. All right? Okay. Still writing recursive rule. Oh my lord. Now things are getting interesting. Whoa is correct. Whoa is correct.
Times 4.
65.
Times 2.
Yeah, but we're on this.
And you just times
I'm going to write it like this way first. Hey, I can start it. I'm going to start it. I'm going to start it. You're going to finish it. I got to start it.
Oh, really? No, I think we got the start. Now you.
Okay. I want you guys to fumble around a little bit. Is there a pattern? Find a pattern yet?
Yeah, what do you do?
Four, but then not 65.
Would you say that?
Yeah, kind of.
What did you say, Dina?
Said you square
Swear what? I'm listening.
it. You square the
Oh, that's not 65.
So, like, explain to me how 4 came up.
That's not
Okay, everybody listen to what she says, because she's on to something here. Say it again, I didn't hear you.
You square 2 to get 4.
4 came up by 2 to the what power? Okay. Okay, how did I get 16 based on what was here? Oh, how did 256 come up? 16 times 16 is 2. Oh my gosh. So you're telling me,
I thought that was a 65.
So did I.
Not a 65.
yeah, it's 65,356. I should have disclaimed that before we started. Okay? Yeah, they should make a curly comma right here. Okay? Maybe you want to do that real quick. Make more of a curly comma here. Okay?
Almost.
All right.
65.
Yeah, the 65 is what now.
Okay, so think about this, kids. The next term, A of n, has to equal the term we have. Dina, to get 4, how many terms backwards did you go to get that? 1 term backwards. So if I'm using A of n as my next term, then what would represent the now term? A of what? N minus 1. We were only going backwards 1 term. What do I have to do to the previous term to get the next term, kids? Square it. That is good. That is so good. Okay. All right. So the next term would really be 65,536 to what power? This is going to get out of hand, isn't it? Okay. But I like that you saw the pattern. Now, keep in mind what we talked about when we first opened up. Did you see a pattern here? Like when I said 1 and 4 is what value? 4 and 5 turned into what? Okay, take a look at this one right here. Let's talk right here. Start me at least on this next one recursively.
So what you're gonna do?
A of 1 is what value?
I know how to do this one.
Okay, now let's talk right here. This one's a little trickier. Mac, you sound like you have an
It's
idea.
just what we did over there.
Kind of what we did. Explain what you're seeing right now.
Well, you do 5 plus 6, that's 11, and 6 plus 11.
Okay, are you guys agreeing that 5 and 6 is 11? Are you agreeing that 6 and 11 is 17?
Yeah.
So, okay, so let's just do this.
I already did one.
If I had to do the next term in line, kids, by the way, how many terms are up here?
5.
So if I label them A1, A2, A3, A4, A5, what term would be my next term then? A6. And A6 would be found by taking 28 plus what? Which would be 45, right?
What?
Okay, now here's the deal. Is that next term dependent on just the previous term, or is it dependent on more than just the previous term?
More than just the one.
Okay, so we need what we had right now and what we had 2 places back, or then, right? Okay, so check this out. Kind of like saying the 6th term is equal to the 5th term plus the 4th term, right? The nth term would be equal to the, what's one previous term of A of n? Plus, how many terms prior to the one that I want next here? Okay, this would have been my A of n minus 1 right here, wouldn't it? But this would have been A of n minus, so we got to go back to use 2 of them right here. So we write this as A n minus 2. Okay, so check this out. If I wanted to know what the 31st one was, this would be dependent upon what terms? The 30th and the 29th. Right? Whatever they are. I'm not going to figure them out, but I'm just saying you can't find the 31st term in this without knowing the 29th and the 30th term. Okay? Oh my gosh.
This is so fun.
I think it's cool. By the way, what would the 7th term be then? How would you find that?
A4 plus A5.
45 plus 20. I have a quick question. Are either of these functions either arithmetic or geometric?
Okay, well, I got that right.
No, they're not.
I got the
Okay.
other one right now.
So is it possible, do you understand why then we're using recursive rules to write patterns right here? Because not everything is arithmetic and not everything is geometric. It turns out that there's times that neither show up. Okay? All right, let's see what I have next here. Let's get through example 4, and I think I'm going to stop there. Is that okay? We're on this idea of recursive rules. Tomorrow we'll kind of switch it up and take a recursive rule and go back to an explicit. But here's the deal. Kids, this says write a what, kids? Okay, anytime they ask you to start with a recursive rule, okay, first of all, what kind of function is 30 minus 5n? Is it linear or exponential?
Linear.
Okay, so do you agree that this is going to be some kind of an explicit rule that would represent some kind of a linear function or arithmetic? All right, here's how you do this. This is an explicit rule that we're starting with, okay? Anytime they write a rule like this is considered to be an explicit rule. And the reason it's explicit is because A of n only has how many parts? Just one part. We don't have a start and then we don't have a rule with it. They just say, here's the rule. So if I wanted to know the 42nd term, I would just plug in what? Okay, well they're saying turn this explicit rule into a what? Okay, well I can't do that unless I know at least
The first term.
first term. Okay. Here's what I suggest in here. Okay, step 1 right here. Make a table. Okay, so I'm just gonna maybe start with n, and I'm just gonna go like, I don't know, 1. Go 4 places with it, okay? So I want to know what A of n is equal to. So So what would a of 1 equal to? I plug 1 in, what are you going to get? 25. Okay, plug in 2, what are you going to have? Plug in 3. You guys identify a pattern yet? Okay, so let's just check this out. Okay, so here's the deal. We're starting with an explicit rule, kids. Our job is to take that explicit rule and turn around and write it this new way with a recursive rule. Okay, so in a recursive rule then, so once you have your table, whoops, I want to do a different color there. So once you have the table established, so step 2, okay, and come up with your recursive rule. Now kids, I can pick any star I wanted to. I can pick the first term, I can pick the third term, I can pick the 900th term if I wanted to. It wouldn't matter. I strongly suggest you start with the first term. So we're going to start by saying, okay, our recursive rule becomes the following. Let's set A1 equal to what? Oh. 25. Okay, we all clear on 25? Okay, then the next part of this. Ooh, we better come up with our next term, okay? Guys, how did 20 form from 25? And then 15 form from 25, minusing 5 each time, right? Okay, so I'm going to say right here, by our recursive rule, our next term, a of n, is equal to what? Okay, the previous term, one spot back, the previous term, which would be defined as a of n minus 1, and then the pattern is to do what? Okay. This is what you're used to. Okay, you took what you're used to and formed a what with it?
Table.
You have a table and now you've identified a pattern, right? And once you've established some values in here with a pattern, you can say, oh, we're going to start with this one. And then the rule for this one is that any next term is equal to what you have right now minus what? And maybe write it down here again. This a of n stands for your next term is equal to what you have right now minus 5. Okay? To think of a of n as what comes next, does that help you see it a little bit? If I didn't say a of n is the next part right here, if I just said, well, what's a of n based on a of n minus 1? Would that be difficult? Okay, you guys help me with the next one. Step 1 to turn a recursive rule, or write a recursive rule for an explicit format. Step 1, do what? Table. Here's the table. How many places do you want to go, kiddos?
4 is good.
4 is good? 1, 2, 3, 4. All right, never mind. Help me plug in a 1 there, friends. 0. So 2 to the 0 power is 1 times 7 is 7. Throw a 2 in there, friends.
1.
So 2 to the first power, right, is 2 times 7 is 14. This is kind of written in geometric form already, isn't it? It's kind of like saying, we're going to start with 7 and keep doing what? Doubling. What do you think 14 is going to turn into? Oh my gosh. 28 might turn into what? Okay. You started with an explicit rule, my friends. All right? They're saying, from the table you formed, write what kind of a rule for it now. Help me. Think of this. Okay, how do I find the next values based on what I have right?
A of n minus 1 to the second power.
Close. A of n is equal to, so the next term is equal to what you have right now. What are we doing? What's the pattern? It's geometric, so you can't be adding. Doubling. Multiplying by what? So it's going to be 2 times what? So you put a 2 out front there like that. 2 times the previous term. Okay. Aiden. Yes, you may. Okay. We're done. All right, I think that's a good place to stop today. If you don't have 7-4 done, try to have that done for me tomorrow.